graduated from Pantnagar University and PhD in Agriculture Economics from IRI. He is a 2007 batch of ARS and joined ICR in 2010 in 19th Focus batch. So prior to joining this institute, he also worked at Indian Institute of Water Management, Bhubaneswar, Odisha. And he holds faculty membership also in IRI. Recently, he completed his 2-year deputation period at Niti Aayog with Professor Ramesh Chand, and his research interests include sustainable agriculture production and food demand analysis. He has got many awards and recognitions also at this age. He got first rank in All India Combined Examination for Admission to Master's Degree Program in Social Science and Agribusiness Management Group, and awarded with ICR Junior Research Fellowship. He got gold medal for his outstanding academic performance, MSc degree in IRI, first rank for PhD admission in IRI, first rank in ARS exam in the subject group of Agriculture Economist, got R.T. Doshi Foundation Award for Best Paper published in Economics Research Review, and also got Best Paper Award in National Seminar on Water Use in Agriculture Challenges Ahead, and Dr. J.S. Puthi Award 2013 for his Best Paper published in Journal of Spices and Aromatic Crops. Again, one more R.T. Doshi Foundation Award for Best Paper in Agriculture Economics Research Review, Young Agriculture Economist Award for Outstanding Contribution in Agriculture Economics, and Young Scientist Award for the biennium ending 2019-20 of NAS. So he has got foreign exposure of Cornell University, Bayers, Australia, Potsdam, Germany, where he attended 6th Indo-German Frontiers of Engineering Symposium organized by DST and Alexander Humboldt Foundation during May 22-25 in 2014. And he was a Niti Aayog representative also to FAO, Italy, for global conference on global strategy to improve agriculture and rural statistics. So he has published a lot in very good national and international journals. Also, he has been a member of many societies and big level meetings to give his advice on policy interface. So I would like to now invite Dr. Shivendra Shrivastava for his lecture on this demand and supply estimation based on consumer preferences data. So thank you very much, Shiven, for joining us and agreeing to deliver this talk on this. I'm sure this will be very beneficial for economists, especially young economists, and also for others to know how these things are estimated and the science behind estimation. So thank you very much. Dr. Shiven, you may now continue.
Thank you very much, madam, for very elaborate introduction, and you really made me nervous. So many such elaborate introduction. So
thank you.
I always derive pleasure in interacting with others. So it will be a good experience for me also to discuss with so many people over here. So as you told that we have a mixture of both PhD scholars as well as professors in universities. So I welcome all of you on behalf of Madam and NCAP for this training program. And I hope that you all are having a good learning sessions, at least getting the briefings on the new techniques and analytical skills, improving your analytical skills. So I have been told that I should discuss with you on some of the demand estimation techniques. So I thought that let us have a flavor of both the theoretical aspects as well as then some demo or the hands-on with some one or two techniques so that we can get to know that how the theories of demand and that preferences and consumer behaviors have been evolved over time, and then what are the applications of those type of things, what are the applied part of that, because I personally feel that there is a lots of deviation in theoretical aspects, and once we apply those aspects and actually quantify the any phenomena, that makes it's totally different many times. So we'll see that if we can bridge a gap between the theoretical and applied aspects of demand analysis. So I may request you that if you'd like to on your camera so that see that you all are active on this training program. So I hope the screen is visible to you.
Yes, visible.
In case anybody wants to have any clarification, I will be happy if you can interrupt me in between. So let us make it more interactive rather than one way, because it includes mainly the theoretical aspects and then we'll move to applied aspects. So it is always better to clarify our doubts if we have any in between. So I guess it is 1.5 hour session. So I would like to be selective in things that so that we can complete it both the theoretical and applied aspects of modeling consumer preferences and then estimation of demand on that. So we all know that in economics the basic elements which we study both at graduate level, undergraduate level, and then still in research also we see that the two elements are mainly dominates the any activity, any decision making, and that's the demand and supply. And the interaction of demand and supply, it always leads to an equilibrium prices, and then on that particular price we consume a particular good. So it's all about that. Economy circulates about these two factors, demand and supply, and interaction between demand and supply leads to the equilibrium prices, and it's a dynamic process. We all know it. I hope that you have that much understanding that it's not nothing is equilibrium at a one particular point. It keeps on changing. So many times the demand keeps on changing, many times supply keeps on changing, and that's why the equilibrium price also gets changes. So we need to know that what are the factors which affects the demand, factors which affect the supply. So if we really need to have some interventions, or we really need to understand how the things are changing place, so we go into deeper aspects that how to understand the factors determining supply or the factors determining demand of those things. So for example, we can see that if in case if in a market we have the excess supply of a particular goods per se, so in that case the prices of that will decline, and with the decline prices the supply will contract, and less with the less prices then demand will start rising, and ultimately it will lead to a new equilibrium at that previous price or some other prices, that equilibrium. Similarly, if we can see that in case there is excess demand, so the equilibrium price may go on, or price may go on increasing, and with the increased price, that over a period of time, supply may also be responsive to the increase in prices, and then we can have a new equilibrium at a new some price level. So it may be either due to excess supply or the excess demand, or the less supply or the less demand. So we can see that prices keeps on changing in a market. Sometimes there may be a changes in both the demand and supply, and that's why the equilibrium may be keeps on shifting from one time to another time, or at the same level also, if there is a similar change in demand and supply aspects of that. So these are some basic aspects. Why I am saying is that before we go into deeper aspects of demand analysis, we should be able to know that what are the applications of this particular concept, that why exactly we need to worry about understanding this particular concept. So we do need to have and develop an understanding about demand, because it is one of the most important dimension or the element in the economic theory. So practically, if you see that there may be different subcategories in supply and demand. In supply, majority is from, for example, let's talk about some food items. That supply of food items primarily comprises about production. Then we can also have some import, and then export also leads to the changes in the supply. Then there is some stock variations like public and private sectors, so that we sometimes we do not consume everything, we store it, and then it creates a supply for the next season. So these are the three basic elements. If we have a summation of these things, we can probably get a total supply: production, import, and stock variation. In terms of demand, it comprises of household demand. Household demand means what we all are consuming in a boundary of our households. Many a time we go out and consume anything, then we need to have an estimate on out of home consumption. Then we also use a part of total demand as a seed, feed for the animals, seed for the crop production, or the wastages are also has to be accounted, because a substantial portion of the total production is goes to the wastage. Sometimes a particular commodity is used for production of some other commodities, or it may not be for the final consumption, but for the some other production. Like cotton is used for the production of clothing and other production. So we can see some of the uses of particular food might be for industrial uses. So if you really want to know the what is the total demand of a particular food commodity or the non-food commodity or any other commodity, we broadly need to have estimates on these four components, like what is the proportion of household demand, what is the proportion of out of home consumption, then seed, feed, wastage, and then industrial use. This composition, you need to know that will keeps on changing depending upon the food item. It will never be same. Like for example, that perishable commodities, fruits, vegetables, probably wastages component may be a bit higher as compared to others. For the processed foods, probably out of home consumption might be of the higher proportion as compared to the household consumption or something. So we need to have a specific composition for different depending upon the food item which are going to study. Let me come to some of the very basic aspects of demand, and we all probably, whether we are economist or extension or agri-business, I'm sure that everybody might have read in their undergraduation, or they might be teaching, the professors must be teaching to their students that some of the basic elements of this or the concepts of this particular demand. One is the want, or we say it as a desire to have a particular good or commodity or a particular service for the existence, for the efficiency, and for conventional or the social cultural things are also there. So we can have a desire for many things, and that we can further classify our wants into a necessity, comforts, and luxury. Necessities for existence, we need some commodities like minimum food, some clothing, some shelters for our existence. So we need to have those type of commodities or services with us, which forms a necessity in our lives. Once we have fulfilled our necessity, that existence need for existence, we probably go for some those type of commodities to improve our working. For example, we need LCD projectors or some whiteboards in our classroom as compared to some other conventional or traditional devices. So that we can improve working on the our activities. Or for example, now we have sophisticated models or the softwares with which we can easily run our models as compared to the earlier days where everything used to be on manually. Then there is a necessity of some conventional things. Means for every society we have some socially accepted, appropriate norms. For example, we do have the same dress codes for this military, dress codes for police or school going students, and that those things are essential, and we have a want or desire for those type of commodities. Sir, एक lecture ले रहा था. Then after that necessity, we need we can further classify our things into comforts, like we can fulfill our basic necessities both by the fan or the air condition, but we will prefer air condition because it is better, it gives us more comfort. Or simply we can still go on and classify the things into as a luxury item, like we can prefer our sedan cars versus the hatchback sort of kind. So there is some classification based on some criteria, that wants are the desires, which can be classified as the necessity, comforts, or the luxury. This is also and that depends on the preferences of persons, standard of living of the person, then stage of economic development, country where they are residing, or the time period. There are many factors that influences this one. And one thing, and also there, one commodity which may be a comfort for a particular person, it may be a necessity for other person. So there is nothing fits in that. It will keep on changing. We need to know that it's a very dynamic process. It's very relative process. So whatever commodity is there, it's all because of our conventions. We have classified those things, and it's all relative. That's the key point from this particular thing. Once and as I told that we cannot fulfill all of our demand because this human mind is full of desires, but we cannot be fulfilled. We cannot fulfill everything or every desire, but those desires which can be backed by the purchasing power and willingness to pay by individual consumers, they constitute the demand. So we need to we know it actually. I'm starting from basic just to have a common understanding among us. But these concepts are very much known to us, that once the desire or the want is backed by the purchasing power and willingness to pay, then it constitutes a demand. Okay, so demand as is also a product of time, place, and price. It is the price specific. So it will keep on changing. So if there are different prices, the demand will be different. If there is a different place, demand may be different. So that distinction has to be there. The demand constitute that we must be backed by some willingness to pay and ability to pay, basically. So once we have a demand, once we can purchase a particular things out of our income, then it leads to a consumption. Then we consume those particular goods or the services, and once we consume those things, we derive something. What we derive? We derive satisfaction. We derive utility. So in fact, once we are consuming the things, then it leads to a destruction of the utility, and that leads to a satisfaction of the want. And that is the whole process which we need to basically understand and express in terms of mathematical things, so that we can depict the rational consumers. Okay, so these things are should be clear in mind, that why once we say that take the terminology demand, it means that we are having ability to pay for a particular things, and we can actually consume those things. And once we are consuming these things, so once we are consuming these things, then it leads to a satisfaction. So that satisfaction is the ultimate objective of us, which we satisfy, that which we achieve by consuming a particular goods or services. So these phenomena actually we need to depict in such a way, or through graphical or through mathematical language, so that we can depict it. And by for that depiction, basically, we have many theories available in our economic literature, and one of the basic theory in our economic literature is the well-known, well-established law of demand. So law of demand, we all know that it is the inverse association between the quantity consumed and the prices, and then we must have studied what are the various determinants of demand. So in that way, one thing what I felt when I was a student in UG or masters, that we used to see this demand means it's only one variable, it's only price which affects, but it's not like that. It's a multivariate association or the relationship between the quantity demanded and many other factors. So once we define a particular law, it means it's only because for the simplicity we are doing that. But actually in application, there are so many factors which we need to account for while estimating the demand. It may be own prices, it may be consumers' income, it may be prices of other commodities, it may be consumers' taste, distribution of income in the society, population, then consumers' wealth, credit availability, government policies, past level of consumption and demand, and past level of income. So we can keep on listing any variables, these variables which will have either direct or indirect bearing on the demand. So it's really a multivariate association, and to me it seems that it's very simple to state a law of demand, but once we really need to estimate the demand of a particular goods and services, we need to have we need to control lots of factors, and which makes it more complicated, and it requires a full-fledged methodology which has been developed and is still evolving in the economic literature. So I have planned to give you a glimpse about that, what are the basic things which we need to understand and consider while modeling a demand system. Uh, there is a traditional theory of demand, and there are so many updates, so many advances on the theory of demand. So I will not go very much deeper because we have only 1 hour time. So traditional theory of demand has mainly four determinants like price of a commodity, other prices of other commodities, income and taste. And when we there state association between price and quantity, we assume that we are keeping other factors as a constant. There are some limitations also of this traditional theory of demand. It means that it only examines the final consumer's demand for durable and non-durable goods, of course. It does not consider the demand for the intermediate goods. As we know, as we say that we have many goods which are used as a raw material for producing something, some other goods. So this traditional theory of demand does not consider this intermediate goods. So it considers only the behavior of the consumers for the final demand. So, this over a period of time, this consumer demand is just a fraction of the total demand. So this traditional theory is lacking into this particular aspect, that it does not gives us an estimate for total demand for a particular commodity, particularly for intermediate goods. Then it is a partial approach. It means that it excludes other markets, and it talks about only one market at a time. So interaction with other markets is not that core subject of this traditional theory of demand. And finally, it assumes that firm sells products directly to the final consumers and not to the some middlemen and those type of things, because nowadays that is not applicable basically. So within a theory of demand, we have a theory of consumer behavior or the consumer preferences, because once we talk about the final consumer, so we should have some assumptions, we should have some tenets which forms a theory of consumer behavior. So it is also important because whenever we'll be talking about the market demand, it's nothing but the summation of in demand for individual consumers. So this particular theory of consumer behavior assumes that a consumer is rational in approach. So we don't have any theory for irrational consumers. Rationality means consumer will take any decision based on an expected direction. So that's how we mean by a rationality. So in other words, we can say that given a level of income and given a market price for various commodities, he will always spend his income in such a way that it will attain its achievement, its outcome. In that outcome is satisfaction of the utility. Okay, so given a constraint, here constraints are he is having a given level of income, prices are also treated as given, then he will behave rationally and spend his income or allocate his income or the expenditure among various goods or the services in such a way that he will always try to attain the maximum possible satisfaction. And this is the also known as the LCM of utility maximization. So this particular phenomena is the crux of the theory of consumer behavior. And most of the time, what we are doing in modeling aspect is that trying to depict this particular phenomena and basically trying to what we say represent this rationality behavior through the mathematics or the mathematical equations and solving it through the statistical modeling like econometrics and those type of things. So this is the thing that how we derive and have a basic philosophy about the estimating the demand things. It also assumes that consumer has a complete knowledge of all the available commodities, uh, their prices and his income. So this is the basic assumption that we this theory assumes very strongly that consumer must have a complete knowledge, because until unless he will not have a complete knowledge, how he will allocate his income among the various commodities. Until unless he will not have knowledge about the prices, how he will be allocating this, making this allocative decisions and those type of things. So these are the things which we need to consider while formulating our problem or the models. Then for the decision making, the consumer must be able to compare the utility. So that's how once we'll be able to know that this utility from this combination of goods and service is better than the other, then only we'll come to know whether we are maximizing or minimizing or what is the level of utility we are deriving. So these are the basic tenets, and for that, that economic theory has different approaches which have been evolved over a period of time. We all know about the cardinalist approach, in which that is a basic theory which shows that, which assumes that the utility or the satisfaction which we derive by consuming a thing, it can be measured or the quantified in terms of utils, in terms of money. There are different many theories. I will not go into that. And then another recently came, then after cardinalist approach, it came the ordinalist approach, which says that utility, we do not need to assume that utility can be measurable. It is not actually required, because it's really very difficult that we cannot assign or we cannot quantify the utility, or what are the standards or the tools to quantify the utilities are all objectionable over a period of time. So we have the full-fledged theories on that. So the approach of ordinal theory says that we can derive the same demand function, we can derive the even maximize the utility even by without assuming that it can be measured. Okay, so we do not require to measure the utility, we only require to identify or rank the utility from or the satisfaction from the different combination of goods in the ordinal magnitude. So ranking itself provides everything. Whatever we can derive from cardinalist approach, ordinalist approach gives the same thing. We derive the same demand function, same indifference curve by the ordinal theory. It's that also. So both the approaches give the same results. It's just about there is a difference in the assumptions on that. Let me just after this basic theory of this consumer behavior, let me just represent in this in terms of simple statement, mathematical statement, because that's how we are going to estimate that. So our ultimate problem was that how we can or how a consumer can maximize his utility or the satisfaction given a level of income and the prices. So our ultimate function is that we need to maximize our utility function or we need to maximize our satisfaction. So utility can be written as a function of QX. QX is the quantity consumed of the different goods and services. So here we can assume it as a monetary unit, but it may not, it really does not matter actually whether we need to measure utility or not measure, because ultimately we are going to derive a formula which will give uh, uh, the some equation, some formula in terms of quantity of in outputs and their prices and the income of the consumer. So that will be given the maximum utility for this particular thing. So if the consumer buys about QX of this quantity, so its total expenditure will be what? Quantity multiplied by prices. So that need to be maximized means we will be maximizing the difference between the utility and its expenditure. So QI, U minus QX into PX, we need to maximize. So this is what we have written in mathematical equation, what we have actually stated in the last slide, that consumer wants to maximize its utility. So for that we have some approaches also in in mathematics. So we have some necessary condition. If we need to maximize a particular equation or the function, we can take a partial derivation of that function and with respect to quantity, and then we can make it equal to 0 and solve the equation. We will get a formula, and that formula will be, we need to fit it through the models or something. So we can take a derivation of QU, del U by del QX minus del PX into QS by QS, and we can equate with a 0. So this will be, price is given, so it is a constant. So constant and dq by dqs will be 1. And so dq by dqs equal to price, or this is the marginal utility itself. Change in utility due to the additional change in the quantity consumption is nothing but the marginal utility. So marginal utility equal to prices. This is the basic equation in the demand theory or the economic theory which we have read, which equate the marginal utility with the prices, or ratio of marginal utility and prices should be equal in all the combinations, and that will be the equilibrium, state of equilibrium. So this is a theoretical aspects of that, how we have depicted the consumer behavior into the equations. Any question till now?
No, sir.
Okay, I hope I'm understandable in these type of things, and this is very basic aspect. So if the consumer derives a greater utility from a commodity, he can increase his welfare by spending more on that commodity. So, but still you must be having somewhere in your mind that how to actually get a data on marginal utility, price data we can get. Then how do actually we go on observing these type of things? We don't have any data available with us which gives us marginal utility or the other things. We get a data on what? Consumption of a particular things, price of a particular commodity, income of the things, not on the utility. So ultimately what we are going to do is that we are going to derive the demand functions out of this particular framework. So in microeconomics, you must have noticed that you must be deriving the demand function from the utility function by having a particular assumptions of price equal to mu, and then deriving that curve. That curve itself, we need to write it and solve it in the software. That's the basic thing which we need to do in the demand modeling. So, but before those things, as I said, that we need to portray the rational behavior of the things. We need to represent the utility functions in terms of mathematical language, and we need to derive the well-behaved demand curves. For that purpose, we need to assume things. So this, you take any theory, you take anything, it has to be backed by, it has to be based on some assumptions or the axioms on which only if those axioms are true, then only whatever output you will get out of your model will be true. Otherwise, it may not hold true in that. Okay, so we need to have some understanding about what are the different assumptions behind any model or something. So I will just quickly go through these assumptions so that we can go and address the that hands-on training on that. So first of the preference is that, like we stated in the theoretical aspects that consumer know everything. He has a perfect knowledge about everything. So it means that he need to that prefer he need to know all the options of his preference ordering or those type of things. So suppose there are two bundles of good A and B, and then consumer knows it everything, whether he has to prefer A over B, that A prefers B, or he has to prefer B over A, or he is indifferent between A and B. I means indifferent. So it means that consumer, a particular consumer who is going to take a decision on the particular consumption or the demand of that commodity, he knows, and he clearly knows about whether he knows he will prefer A over B, he will prefer B over A, or A is indifferent B. So he will choose one and only one option out of these all the things. So this is called as a preferences of completeness assumptions. So you must be thinking that why do we require this? What is the purpose of this type of assumptions? Purpose of this type of assumption is that if we need to really portray the rational behavior, if we really need to draw an indifference curve which is convex to the origin, which is downward sloping, it has to be based on these things. If these conditions are not hold true, then we cannot draw a downward sloping convex origin, this indifference curve. Then second assumption which must fulfill that preferences are transitive. It means that if a consumer prefers A to B, and then if he prefers B to C, he cannot then he will prefer, or he will always prefer A to C. Okay, these are the transitivity. So this transitivity means that he can take a decision, and that decision cannot be hold back. Means he cannot if A is preferred over B, B is preferred over C. So A will always be preferred over C. It's not like that the C will be preferred over A. Otherwise, it will not be a rational choice of a consumer. So if we need to represent a consumer's rational choice, these conditions has to hold true in that. Then we should have a assumption on the preferences of continuous. Continuous means we have two variables, discrete variables, continuous variables. So discrete variable, they will be, we cannot draw a smooth curves like these curves are there. For that we need to have continuous variables, which so for that the assumption is that if A is preferred over B, and if C a combination lies in a epsilon radius, means very close to B, so A will also be preferred over C. So if A is here, B is here, and nearby if C is there, so A will also be preferred over the C. So these are the things actually are the assumptions, and if we need to derive the things, write a good function, then these should be fulfilled. And once these conditions are fulfilled, then we can have a well-defined utility function and an indifference curve that cannot cross each other. So indifference curves actually should not cross each other, which we have read in our microeconomics, that they have to be something like that, shaped in the pan shape, and not disconnect that cross into each other. If they are crossing to each other, probably we cannot portray the rational behavior of the consumer. Somewhere we are deviating from our assumptions. So if we do not deviate from our assumption, if we really need to portray our consumers' behavior, so we need to ensure that we follow these assumptions on that. So we all know about the definitions of indifference curves also, that indifference curve is the locus of consumption bundles that generates a utility level of same utility level. So utility level will be same on this IC1. You choose any combination of commodities X and Y, it will be given the same utility. So now based on the budget constant and the income constant, that consumer can take a decision on which combination which he is going to see. If he moves on the upper indifference curve, utility keeps on increasing. So this is the indifference map, and on this indifference map actually consumer has to take a decision what should be the combination of commodities he should choose actually. So before choosing a particular combination of goods, he should be given that black box, no? And that black box is the indifference curve or indifference map. And for making a good, well-behaved indifference map, we need to follow those theoretical tenets, and that's why is the purpose of this particular we are talking. For example, let's see that whatever we are seeing that I have told that we cannot have indifference curves which are what we say this like crossing to each others. Okay, so let's say that why it is not possible, whatever I have said, that why there should we should have the well behaved this indifference curves. So if we see this suppose this is a two indifference curve and we have a bundle B, A, combination of commodities at point B, point A, point C and point D. So here what is that? A is on the upper indifference curve. It means that utility derived from the A will be higher than B. So A will be preferred over B. Okay. B and C are on the same indifference curve. So consumer can choose either B or C because both the combination of goods will give the same consumption level or the same satisfaction level. Okay, so we what preferences will have? A will always be preferred over B because A gives the higher utility, and consumer's rational choice is that he will always try to derive the higher utility. So he will choose A over B. Between B and C, he is indifferent. A consumer may choose either B or C. Then if we see the difference between C and D, here C is on the higher indifference curve as compared to D. So C is always preferred over D. And then we have D is indifferent over A. Means A and D are the same and C are the same. Now, if we assume that, suppose let us assume that they can cross to each other. So what will be happening that if A is preferred over B, B is indifferent over C. So as per the transitivity assumption, A should be preferred over C. Okay. So once C is preferred over D, okay. So A should also be preferred over D. Okay, you got it now? A is preferred over B, B is indifferent to C, so A is preferred over C, and C is preferred over D. So A will be preferred over D, but here A and D are on the same indifference curve. So which is contradictory to each other. So here there are two things. I am saying that A is also preferred over D, and we are also saying that A is indifferent to D, which cannot be possible. So for depicting the rational consumer choice, it should always be there. These indifference curves should not cross to each other. And for that, if they are not crossing, it means that we are depicting consumer choice in a better way. Somebody saying voice is not coming. So am I not audible?
Yes, sir, you are audible.
Okay, okay. I just have one message. Okay. So those three assumptions, that completeness, transitivity, and this one more was what we say this continuous, were basic assumptions for which we need to have it, which we need to fulfill. Apart from that, we have 2 or 3 more axioms which are not means must for deriving the thing, but they are useful functions, like assumptions are of non-satiation. Non-satiation means consumer always would prefer a large amount of goods or more amount of goods as compared to less. If he is having an option, if he is having a ability and willingness to pay, if more is there, he seems that better is the case. So in the layman language, this assumption says that consumer always places a positive values to the more consumption as compared to the less consumption. In mathematics also we can express like this. If suppose there are 2 bundles A and B which composed of 2 goods X and Y. So X means XA means amount of X good in bundle of choice A. Similarly amount of B X amount in choice B. then y is the amount of y in bundle A and amount of y in bundle B. So if we have a commodity or the amount of good A and amount of good X, both are same in A and B, but amount of this y is in bundle A is higher as compared to amount of y in bundle B. So his natural choice will always be that he will always prefer a bundle A over B, because he is getting the same quantity of goods in both the bundle of good X, but for the good Y, he is having the getting the more quantity of Y as compared to in bundle B. So he will choose the he will prefer A over B, regardless of the level of XA, XB, YA, and YB. So this is some mathematical jargons. Simply speaking, it sees that indifference curve will stretch out endlessly. So it means that there will always, it's not like that for a consumer, there will be only 3 curves. It's all about the convenience. There will be endless number of curves which you can make it. And that is possible if we have the assumption of non-satiation. So this is the basic behavior of the consumer, that he always prefers that large volume and large level is always better than the less. Then we have the diminishing marginal rate of substitution, which is important if we really need to have a convex origin indifference curve. That rate of substitution between the goods X and Y is diminishing at the diminishing rate. So that if we have this assumption, that in indifference curve will be convex. So in our theoretical textbook, we actually have read all those things, that indifferent properties of indifference curve. That is what actually I am also saying. We have the convex origin, they should not intersect and those type of things. So what I have come to know after going into details of this theory, that all those properties of the indifference curves are to depict the rationality in the choice of the consumers for any combination of goods. Here you may also think that why we are taking only X and Y. We consumer do not consume only 2 goods, so it is only for the sake of simplicity, that he can have this any number of goods and consume any number of goods on that. So this is all about what we have discussed, is that we have made a statement about the rationality of the consumer, that consumer behaves rationally. It means that he wants to maximize his utilization or the satisfaction given his constraints on income and this prices. In that constraint, we need to depict it mathematically. For depicting those rationality behavior mathematically, we need to fulfill and some of the axioms, we say it as assumptions on that. So that's what we have discussed till now. Once we are able to write down our utility function, constant function, then it comes the challenge of that how we solve those equations. Okay, so we have the simple example. We have one method also solving the maximization problem or the minimization problem. You must have read those things. So we have a Lagrange multiplier method which help us to solve these type of problems. Okay, so let's say, for example, suppose we need to maximize a utility or function z. Let us forget about utility function or other things. So simple mathematics, we have a Lagrange multiplier method. Suppose we need to maximize a function called z, which is a function of quantity of goods X and Y, subject to the constraint S plus Y less than and equal to 100. Okay. So for this, we have a Lagrange multiplier method, in which what we do, we add an extra variable or the Lagrange multiplier, write a new function, and then take a partial derivative with respect to different variables, and then solve the equations. So first step is that we create a new equation from the original information, that is L is a function of xy plus lambda x minus 100 minus x minus y. How it came from here? So we have actually added this one equation and this equation. So new equation L is the name, just we can give any name, is a function of f into xy get function plus this is the new variable we have added, Lagrange multiplier. Then we will write in this way that 100 minus x minus y means this left and right we will put it into in terms of equations. Then what we will do, we will have a regular maximization problem, take a derivation of this function with respect to, let's say, x. This is not complete, this is the small d partial one. So will be a function of x, means y will be a constant, it will go up, minus x means this will be 0, this will be 0, and this will be minus x means minus 1. So what we will have, derivation of d lambda by del x will be minus 1 into lambda only, equal to 0. Similarly, we will take a partial derivative of this function with respect to y, and then it will be function of y, x will be constant, so it will be 1, minus plus, it will be plus but multiplied by minus 1, 100, it will be 0, oh sorry 1, minus it will be 1, and then it will be sorry, it will be 0, and then it will be what we say, minus 1 into y, so it will be lambda 1. Similarly, once we are taking partial derivation with respect to lambda, this will be 0, and this will be 100 minus x minus y. Once we have these three equations, we always have a procedure in mathematics for solving the simultaneous equations. So those simultaneous equations will be solving and getting the value of x and y and lambda. This value of x and y will give us a maximum level of z. That is what we derive it in mathematics. So ultimately, our steps to address this problem is that first we will define our objective functions, constraints. Then we will solve those equations and derive the quantity of optimum quantity of the x and y, which will give a maximum level of z. This is the approach which we usually use in our utility maximization. Let's have an example on that. Let us write a function maximize u is a function equal to 4x square plus 3xy plus 6y square, subject to x plus y equal to 56. Okay. So what is our Lagrange equation? Simple. 4x square plus 3xy plus 6y square plus lambda will put additional Lagrange function and plus 56 minus x minus y. Then we'll take a first order partial derivative and set them equal to 0. So what will be the Lx equal to, means dl by dx equal to 4 into 2, 8x plus 3 into y, because x will be 1, minus this will be 0, this will be 0, this will be 0, it will be minus 1, so it will be minus lambda equal to 0. Correct? Similarly, dl by dy, we will take partial derivation with respect to each variable with us, x, y, and lambda. We have the 3x, it will be 0, 4x square means with respect to y we are taking, so this is the constant. Then it will be 3x plus 12y minus lambda equal to 0, and then it for this lambda we will have all these three equal to 0, and then 56 minus xy minus y equal to 0. So now we need to solve these three. For the solving, we know is that 8x plus 3y equal to lambda, 8x plus 3y equal to lambda, then we will equate this equal to this usual simultaneous equations, solving of this x equal to 1.8y. Then we'll put this x value in any one of these values. Let us put it in third, and then we'll get the value of y. Once we have the value of x and y, we can always also derive a value of lambda also. So we have the optimum value of x, particular value of y, and these two value means 20 and 36. If we consume get a value, this 20 and 30 is the value which will give the maximum value of utility function. So that is the simple mathematical model which we need, which we use and apply for utility maximization. No query? Okay, so let us put that mathematical equations in terms of our original problem in which we want to use this Lagrange multiplier method in solving the consumer choice problem, in which what we need, we should have a utility function. For example, let's assume that we have a utility function of multiplicative type u equal to x into y, subject to b into px into x plus py into y. Lagrange multiplier will have it xy plus lambda b minus this into this. We will write it into same way like we wrote it earlier. We will get a formula for x which is equal to b by 2px. Formula for y, b by 2py. What do you know this? What is this b? Let's say this is the budget, total budget of an expenditure. Total expenditure is what? Multiplication of price and quantity on various goods. Here we have only two goods. So if we suppose we have only two goods in question, so total expenditure of the consumer will be the multiplication of price with the quantity demanded equal to their total expenditure. So total formula which we will have for optimum quantity of X will be the B by 2PX. It means that B is the total expenditure or total income of a consumer. So you know now in the basic theory of this demand theory, which says that quantity demanded is a function of inverse, it is inversely related to the price of X. So you can see this by, it is 1 by 2 of PX. Then quantity demanded of a good is directly related to the income or the expenditure of goods. So these things are means as per our basic consumer theory, which we have stated earlier. So if we follow this utility maximization approach, we will get a formula for getting or estimating the quantity demanded of a goods in terms of some other variables, like for example here we have price and the income or the expenditure, which will be as per the economic theory of demand, and that is what we needed. So now what we got? We got a formula for, and that with the variable like x is the quantity demanded of a commodity X, quantity demanded of a commodity Y. We have a variable B, we have a variable PX. B is the income, PX is the price. All these variables we can quantify, we can get the actual data on these variables. We usually get the data on these variables and then estimate the functions. We cannot get a data on the utility and those type of things. But whatever quantity we will assume, it will give the maximum level of satisfaction to the consumer. So once we have this type of formula or the functional form, whatever of that level of inputs of this food, we have this, this commodity level we have X and Y, it will always give a maximum level of satisfaction. So by applying theoretical tenets into the mathematical with this, for example, this Lagrange multiplier, we will derive a formula which will be used for estimating the demand. So that is what theoretically we are shifting from theoretical points to applied aspects of those things. In economic theory, you might also have read about Marshallian demand function or Hitchian demand function. In Marshallian demand function, this we have this uncompensated income, or in Hitchian we have a compensated income. So compensated means you must have seen that derived is keeping the income level fixed at the same indifference curve and then deriving the optimum combination of goods X and Y. So those things are actually we can get it here in terms of formula also, because here we have both the income and the prices. So once the quantity demanded is expressed in terms of both the income and the prices, we say it as a uncompensated or the Marshallian demand function. But sometimes what happens, we go for compensated income, means we deflate the income, we remove the income effect, and then we see what is the demand for that. So that type of demand function is known as the Hitchian demand function or the compensated demand function. So for the compensated demand function, we have other sort of derivation. You must have read in linear programming, we have the duality theory. We can always write a dual to the primal solution. So if we assume this problem is a primal problem, maximization one, and then the same problem can be written in terms of maximization problem. So this is a maximization of utility with respect to budget equal to ps into x plus py into y. But here we can same thing, either instead of maximizing the utility, we can minimize the budget with the given level of utility. So either we can maximize the utility with a given level of budget, or we can minimize the budget with a given level of utility. So if we know this, what should be our minimum budget, so that we can derive the same level of, or define a given level of utility, we can solve the same problem with the minimization or duality of those type of things. So we can convert this maximization problem into the minimization problem, apply the Lagrange multiplier, solve the equation, derive the formula, and get a formula which will give us a, this is nothing but a demand function for the good x, demand function for the good y, and we say it as a consumer's Hitchhian demand function or the compensated demand function, in which we have compensated the income of the consumer and put him on the same given indifference curve. So in that you will not get a coefficient or the thing for income, you will get only prices and for a given level of utility, which is utility 0, at which we have fixed. So this type of formula we get it from the minimization problem. So I am doing nothing, I am just trying to depict the things through the mathematical operators. If we need to derive a Marshallian demand function or the compensation uncompensated demand function, we will use the maximization problem. If we want to derive the consumer's compensated demand function or Hitchhian demand function, we will use the minimization problem. And because of these different approaches, different functional form, because this is just a one functional form. If we change this functional form, it will be different formula. And you know there are different functional forms which we can assume. We can assume the simple linear function, log function, which is Cobb-Douglas function, logistic, translog, quadratic. There may be many functions. So in literature, there are numerous several forms of models are there with the varying level of assumptions on the functional forms and type of demand estimation. So you need to choose one among whatever suits you, and but basic approach is either maximization problem or the minimization problem. So this is in general, I will skip it. Any query till now, that theoretical aspect, so that we can move to the second aspects of it. No? No query, no nothing, no comments. I hope you all are there.
Yes, sir.
Oh, at least respond. I should know that whether people are here or not, whether you are following it or not.
Yes, sir.
Okay. Yeah. Okay then. So as I said, this we have this theoretical aspects, and then based on our functional forms, based on our maximization minimum, our approach, which we are assuming that there are so many models in available with us. Some of the models do not take into account these economic theories, like simple time series model. We can take simple, suppose a demand of a particular product, one product, for example, milk is there, is a function of price, income. You fit a simple function, okay? You can get some elasticity and see that this is the demand model for this particular good. Single equations models are there. But you know this, while estimating the single demand model for one particular good, that you assume that consumers are not treating taking into consideration other food products or non-food products. So it is not true most of the time. So we need to have a model which we can use it and simultaneously estimate all the goods into taking all the goods into consideration. So those type of things are there. Then we have simple models also. We have some complicated models also. Simple model, as I said, you can simply run a single equation, one equation model without a choice of functional form. Because most of the time, which we assume that if we choose log log function, it is okay. But many times it is not rational or practically depicting the consumer's choice. So then we have a demand functions which uses theory of demand, as we have said, as a guidelines. Like we have the linear expenditure system model, we have the AIDS, means almost ideal demand system models, and derive the in which this model derives the estimable functional forms of demand equation. Like we have derived on the simple one. This AIDS model derives the functional form using the minimization problem, and then we put a constraints on demand parameter. Whatever I will come into that how we do that. We derive a set of equations. We solve those set of equations by imposing some of the constant. And imposition of constraints means we are trying to fulfill the assumptions of the demand model or the assumptions of the demand model which we have said it that. So that way we have the approaches, we have the clear-cut steps and guidelines for estimating the demand equations. So we have so many models. I will not go into that the basics of each model because one model itself is a big takes lots of time to do that. So these models, as I said, this LES, AIDS, those are for the final consumptions. Then we can also estimate the demand for inputs like labor, capital, seed, like in agriculture, we do those type of things. For that, we can estimate either cost function or the profit function. And then using those cost and profit function, we can derive the demand for inputs like price elasticity, I mean, for these particular inputs. So we have different categories of that. So for that, today's my job is to give a glimpse of all those things so that if you are really interested in a particular model for suppose LES or AIDS or time series or the input demand model, you can further go into that and see that. Even I can also assist you in case you prefer to that. So we have some of the approaches. Model means that we will estimate the elasticities, either price elasticity or the income elasticity. Then one of the use of those price and income elasticity is that we need to get some projections or the estimations of the demand. We say that suppose we need a demand forecast or a demand projection for the future 10 years, 20 years, or tomorrow or day after tomorrow. So we need to have that demand estimations and demand projections. So out of these four components like household demand, out of home, seed and industrial use, the maximum biggest thing is that household demand because we need to fulfill the basic tenets of the demand theory. So for that also we can go from the simplest way to the more complicated ways. Simplest way will be that what approach will that simplistic approach means simple we can take the what is the per capita consumption expenditure consumption of a particular good, then we can multiply with the population and tell it this is the total food demand for this particular year. So that is the most simple way. Okay, we take the actual consumption multiply with the population. Then we have the normative approach. Normative approach means what we can say take it that we can take the minimum amount of nutrients or the energy which a body requires. For example, we require a minimum amount of calorie daily we require about 2200 to 25 kilocalories per day as a minimum calories for our norms are there, the recommended dietary norms. So what we can see that by normative approach we can estimate the quantity of the goods which can or the food commodities which can give us that minimum calorie or the nutrients intake. So we can estimate or derive the minimum demand for that, because we all demand minimum amount, at least minimum amount of food to exist in the nature. So if we follow that approach, we can have a normative approach for that. And then most popular approach is the behavioristic approach, which is what we have discussed now, that we need to depict the rationality of the or the consumer's choice or the consumer behavior of the what we say consumers into the equations, and then estimate the price or the income elasticities, and then estimate the food demand projections or the demand projections for any other commodities. So if we want to see that how the consumption pattern is changing due to the change in income, demographics, social changes, and we want to capture those type of things, we should go for the behavioristic approach. And behavioristic approach in the simple sense is nothing but estimating your elasticities. For example, income elasticity, it will give us that when the income changes, how much can be a change in the demand. You then have some other formulas to include those estimations for estimating the total food demand. Then we can have indirect food estimations, like we can identify the uses of seafood, processed foods, industrial uses, some standardized coefficients, apply those coefficients and convert in terms of food items. So I will not go into this. First, then we can add direct and indirect food and estimate a food demand estimation into. Sometimes we have some sophisticated modeling approach in which we need to have a framework basically. Why it is required? We have the multi-stage budgeting framework. Why it is required? Because as I said, we have the model for single equation, we have the model for multiple equations. In real life, what happens? One consumer is having choice of many items together. It can, it has to take decision on many items, which are related, some are non-related. So we will have a many more, so many number of equations we can virtually or practically cannot estimate. So for that purpose, we use a multi-stage budgeting framework, which is something like that. Suppose this total consumption expenditure, we can always categorize into food expenditure and then non-food expenditure. We can have some one model for stage one, in which, let's say, food expenditure is a function of total income, non-food expenditure, demographics and others. Then in the stage two, out of food expenditure, consumer can allocate among the cereals, pulses, edible oils, milk, non-veg, vegetable, fruits, because he has to consume minimum of each of these subgroups. Okay, so at second stage we will have some mathematical modeling. I will come to that. And then suppose, for example, we are estimating third stage individual pulses. Within the pulses, the consumer allocates among the gram, arhar, moong, urad and others. So this way we can simplify our models. We can reduce the degree of freedoms, and we can practically estimate for that. So suppose if we are going to estimate demand models for pulses, for example, individual pulses, we can have it in have our estimation in 2 to 3 stages. First stage, we can estimate the total expenditure pattern between food and non-food, and then between the different subgroups of food item, and then within the subgroups individual pulses item. So that's how we go for this estimation. This is the just a graph that broader depiction in terms of equations. That first stage, suppose food expenditure is a function of income, prices of food, non-food and demographic variables. Then in the second, suppose group wise cereals consumption will be a function of prices of the cereals, prices of the pulses, and then estimated F. Estimated F means from the first stage, whatever will be the estimated coefficient, we will use that estimated coefficient here. So what is the effect of these variables in on F will be included in this particular estimated one. So then we will have the estimated CG, and then estimated CG we will put it in the third equation, estimated one. So that's how we have a system of equations, and that system of equations we will be then put in some restrictions for example, homogeneity, symmetry, and adding up. These three restrictions are added or constraints are added so that we can have a well-defined demand functions. I'm sure that this will, for those who are new to this particular thing, will take some more time to understand. But let us understand what is the approach and idea behind these things, so that once you actually do this, you can go and get into more. What do you mean by homogeneity, symmetry, and adding up? So these all restrictions are just to portray the rational consumer behavior in terms of equations. For that, we do require these type of derivations and restrictions on that. Once we estimate these things, then what we'll do, we will have these formulas. These formulas are for EITS model. For each model, we have different formulas. So depending upon your model, you will have to choose the model and get the formula and then estimate the whether you want to have the Marshallian demand, then you will use this one, uncompensated price elasticity. Compensated price elasticity means it does not have an impact of income, and this is the Hitchian demand model. And then the expenditure elasticity using this one. So W is the share of this particular equation, particular good in total budget. So ultimately, suppose from this particular model, what we will get, suppose expenditure elasticity. Then getting by using this expenditure elasticity, which is E, we can have a forecast of those demand. The forecast of those demand, suppose demand in a period T means future period will be a base demand in the base period, suppose this year, then total population in the future period plus 1 plus per capita change in income. Because this is a behavioristic approach, we expect that with the change in income, our consumption pattern also changes. We will use this expenditure elasticity estimated from the last stage, and then change in income will be this multiply, and then we will compound it with the year for which we are going to estimate. So this is a theoretical that approach for estimating the demand forecast. I have seen that Egypt used for more than 2 commodities. Certainly, actually, this particular one person has asked that whether it is used for more than 1 commodities. Dr. Ganga Devi. Certainly, because these are the 1 commodity in this particular stage. This one, stage 3. This is SI. SI means there are more than 1 number of commodities. So whatever number of commodities you have, you will have that many number of equations. So here how many commodities are there? 1, 2, 3, 4, 5. So stage 3 you will have the 5 equations. The stage 2 you will have 1, 2, 3, 4, 5, 6, 7 equations. So stage 1 there will be 1 equation. Stage 2 there will be more than 1 equation. Stage 3 will be more than 1 equation. So it's all more than 1 commodity. So ultimately whatever elasticity you will get after accounting for all the commodities together. So we are estimating demand for all the commodities together, so that then only we can portray the consumer's choice. Until unless we cannot compare the things of utility, how he will make a choice. Okay, so that way it is for more than 1 commodities. So now I will what I plan that I can show you that how we can use this as a. We still have some time so that I can. So from those models, actually what we get is that we get the demand projections. So if I need to show you some demand projections, so we get, I will show that how do we get this elasticity. This is the expenditure elasticity for suppose cereals. We have estimated only 2 stage function, first stage and second stage. And second stage we have used the cereals. And cereals we got this elasticity, income elasticity we say it, okay. So before showing to you that how we can estimate elasticity, let us see that what is the use of those elasticity. Okay. So use of that elasticity, as I said, this is the formula for demand projection. So northwest, what I did in one of the analysis that for rural urban, different regions of India, we have projected the demand for cereals. So using this elasticity and some other assumptions. Okay. So here we have 2004 NSS survey. Using the NSS survey, we have what is the per capita monthly consumption of cereal. In North, let's for example, we have it 12 kg per capita per month consumption. We can convert it into yearly basis. Then we have a population for the year 2011 for the future year. So I use the base year was 2004 and 2011 was the future year. Okay, so we can have a growth rate in population between 2004 and 11. We will use it later on. Then let's say population for the year 2016. This is the population growth rate between the base year and the 16. Then 20. Likewise, growth rate in population we can estimate. And then income. So base year was 2004. Let us say this income between 2004 and 11 was 7.25. So this is the total income. We can estimate the per capita income because everything is in terms of per capita. So how we can estimate per capita income by minus growth rate in income, total income minus growth rate in the what we say population. So that is what we get the per capita income growth. Similarly, per capita income growth between 4 and 16, 17 by income growth minus this one. And then we have the elasticity. Using this formula, then we can estimate the total projected cereals in 2011 in terms of million tons. I converted per capita into millions by applying this formula. So this is for the 6 years away from the base year. Means 2004 was the base year. So estimated for the 6 years away. So it was a 33 million tons for the North India and rural areas. Then for 16 it was 37 and 40. So my purpose to show is that using this particular formula, once we derive these elasticities, then our own assumption basis we can estimate the projected food demand. Then we can develop different scenarios. Like this is a business as usual, means actual growth in the income. We can assume higher growth, we can assume slower growth, or we can assume the differential growth in the population. So depending upon our analysis or our requirement, we can estimate these things. Yeah, somebody asked that can you practically show the how the elasticities are estimated? I'm going to do that only. I'm going to show you that for that we require some software. So I particularly use SAS software. I do not know how many of you are using this SAS software, but I will show you that how to use this one so that if you are interested, even we can take other lecture as well as so this is the SAS software. Now I'm going to use some of the simple demand functions so that you can get to know that how it is being run on this. So in SAS, we have different windows. We need to write programming for that. So probably I'm sorry, I cannot go to tell you that how to write codes and other things. So that maybe we can discuss some other time. But at least my purpose is that if I can show you that how we can run the simple model. So this is the our code. So before that, let me show you. Can you see this Excel sheet? Can you people see Excel sheet? No or yes?
No, sir. Excessively no, sir.
Okay. Now?
Yes, sir.
Okay. So I have one small example that we have the information for the years 96 to 2004, 10 years of data. We have different milk products. For example, we have the milk products for cheddar. Cheddar is a type of cheese or some item made by milk, like what we say paneer or something. Then we have some processed milk or something. We have butter with us, and then we have milk. And this is the quantity demanded of each things, like quantity consumed. Quantity consumed for cheddar product is this, quantity produced by processed milk is this, milk is this, butter is this, milk is that.
It's
And
cheddar
this is,
and this processed diet is a cheese actually.
yeah, cheese. One is
Cheddar
cheese
cheese.
and one is some other substitute of cheese. वो foreign में कुछ खाते हैं वहाँ पे. Then we have the prices of each this different products, like price of butter, price of cheddar, price of this and that. So simply, if you need to estimate total expenditure, which is synonymous with income, we can simply multiply price multiplied by quantity. So by doing that and summing over everything, what we will get? We will get a expenditure on total expenditure. Using this particular thing, now our thing is that can we derive the income elasticity and price elasticity of these particular things by using some demand models, simple demand models. Okay, this is our problem. So let me just go to this thing. Says so here first we need to import our data set. Let me import it. सर आप लोग ने साइंस में क्लास ली है क्या इसमें अभी? सुभाष सर
So,
it takes some time to because it is shared and so for still working with SAS, we need to import that file into this SAS. So the same file I have right now in SAS, like year, observation, cheddar, process, milk and milk. So these are the variables. This is the quantity and this is the price of that. Okay. So now what we are doing is that these are the some set of demands. Here what I have done is simply estimated total expenditure. Total expenditure made by consumer is that quantity multiplied by price plus quantity of this product multiplied by price of this product, quantity of this multiplied by this plus butter and butter. So if we add an aggregate, it will be total expenditure. So for estimating the expenditure elasticity, we need to have or derive a new variable which is estimated. Then suppose we are estimating log function model, functional form. Suppose we are estimating log. So we'll estimate new variable log milk will be equal to log of milk quantity, log cheddar, log of cheddar, log process, log of process, log butter, log of butter. So if I run this, I will get new file named the dairy in which we will have these variables as an additional variable to each other. So if I select this and run this is the run button, submit button, and we'll get the new file here, and which will have earlier you had these files. Okay. Now you have new variables also. This log expenditure. This expenditure is nothing but what? Summation of product of price into quantity. It is a 76, 77, 82. Then we have log of those things. new this thing. So what I have done, I have created some new variables out of the existing variables on price and quantity. Now what I have, suppose we have unrestricted double log demand. Unrestricted means, as I said this, if you want to fulfill the demand theory, you need to impose certain restrictions so that we will be able to portray the consumer's response or the consumer's decision. In this particular example, for example, we are doing unrestricted, means we are not trying to impose any conditions or the restrictions of homogeneity particularly. Homogeneity means if you have read the economic theory, there is a price illusion, means no money illusion. Means if you increase the price and income by the same proportion, it will not have any impact on the demand. So I will suggest that these things actually we should know some more aspects of demand so that we can impose or not impose. So here we are not imposing. We are simply running a model using the data in this. These are the models for each equation. As somebody asked that, can we estimate model for more than one commodities also? Here what we are going to do, we are going to estimate demand elasticity for all the 4 items together. Okay, so here are our equations. First equation is that log milk means quantity demanded of the milk in log form is a function of AM, means A plus, we write it now, A plus BX plus C. So this is a coefficient of income. Then this is a B coefficient which we need to estimate into log of expenditure. So this coefficient will give the asset elasticity of expenditure elasticity of milk. BC is the coefficient which will give us the expenditure elasticity of cheddar. BP is the elasticity of this. Likewise, we can estimate the expenditure elasticity. Then for the price elasticity, we can simply run this one, means GMM, so GCM. So we need to estimate these coefficients for the price elasticity. So own price elasticity of milk will be given by GMM. Cross price elasticity we can also estimate by GMC. If we can estimate this coefficient, it will give the log cross price elasticity of milk with respect to change in the milk price of cheddar. Then price elasticity, cross price elasticity bill of milk with respect to processed, and likewise butter. So we will estimate these things. Then we have some technical things like we need to define the parameters like AM, BM, we need to estimate. So we need to write it here. AM, then first BM, then GMM, this one, then GMC, this one, GMP, this one. Then for second commodity, we can write ACBC, like for first equation and the fourth equation. So these are the parameters which we need to estimate. We need to define which this is endogenous, when is exogenous variables. Endogenous variable is log of milk, log of cheddar, log of process. For each, these are the endogenous. Then exogenous are all these: milk, this, milk price, cheddar price, process, butter, and expenditures. So these are the things. We need to fit this model using the simple. Let us see the simple OLS, and then save our estimates in some other things. So if we run this particular, we will get some estimates on that. It will take some 30 seconds or something. So So once the model is being run, we can see that what are the steps the software is taking. So it is an iterative decision that convergence criteria is met, and now results will be publishing. So it will give us some results. Till then, any question you can ask in case. Any query or comments, if you could not get anything also you can tell me.
Sir, there is one question.
Yeah.
Answer. How much convergence level should we go for?
It's all depends on your thing that there are some standards given in each software. SAS it's 0.001% change between actual and efficiency parameters. So most of the software is predefined actually. So now we get the results here. You can see. I hope that this screen is visible.
Yes, sir.
So we can see the whatever summary of the models. So model variables were 9. Total number of variables which have estimated is 9. We have this endogenous 4, means there were 4 products. These is the model variables. These are the parameters. 24 parameters have been estimated, which were there in the 4 equations, and number of statements were 4. So this is the form of the equation. This quantity demand of the milk is a function of this AM1, BM, and other. These are the estimated parameters for milk, then for cheddar, then this and this. OLS criteria met, so it means that we could successfully run the model. And then these are some other parameters like R square, RPC, objects, and other things. Number of observations were actually really less. So this is just a demo example, so we don't need to worry. But 10 observations virtually will not get much of the things. Okay. So these are the estimated parameters like AM, BM, GMM, GC. So for example, now you need to see what is the price income elasticity. Okay. So what was the income elasticity coefficient? Income elasticity coefficient probably will be given by this. Suppose we need to have income elasticity of milk. So it will be given by BM, coefficient BM. So coefficient BM gives the 1.7, which is significant at 1% level. So 1.7 is the income elasticity of milk. So suppose what is the price elasticity of milk? It is a GMM. GMM is the 0.98, 0.89. So it is a price elasticity of milk, which is significant. So likewise, we can have the different income elasticity and price elasticity of each one. So we know it through theory, we know it that income elasticity or expenditure elasticity is positive. For milk, it is 0.17, which is more than that. If price elasticity is negative, which is 0.89, which is significant. Okay. So that way we can estimate we can get this variable and take this elasticity from this particular model, then use this elasticity for other things. So this is the very simple model. This is just an overview of that. We have used the OLS. We have not imposed any restrictions. Suppose now if we need to impose a restriction on that. So restrictions in the means homogeneity is a restriction to portray the consumer behavior. We say is that we express everything in relative terms, means we will divide prices of every unit, every value in terms of prices of butter. It means that we will express total expenditure in relation to the prices of butter, price of milk in relation to price of butter, price of cheddar in relation to butter, price of process in relation to butter. So we'll estimate these again variables and see that how it is done. And then what we have done, simply homogeneity restrictions means, in layman I will tell that homogeneity means that if you multiply price and income, increase price and income in the same level, it will not have any impact. And this is a rationality behavior and this has to be imposed. That how we do it that is that we deflate in all the commodities in terms of with price of any one commodity. Then we run these type of things. Okay. Then once we are running is that we will run this model, and then I will return an IML command. It is whatever, suppose this is for in this format, for expressing it in some other format, I can run it in, write it in IML. I will not go into IML because it will, we have already exceeded our time.
Okay.
So I will just quickly run it and show it to you that how it has run it. Can we estimate elasticity in SPSS and Excel? You can run it simple models in Excel, of course, but for this estimating different models for the means more than one commodity, you need to write codes for that. And I think code means you should have this in Excel also we have macro and other things. No? So for macro, we need to write those macros for Excel sheets. SPSS also similarly you can estimate, but you need to write your own programs. So many times it's a menu driven thing. So if you don't have the simultaneous equations modeling aspects, then you need to write your codes. If it is there in menu driven, then you can write. I will suggest all of you to learn and work with R, because once we know the basics of R, we have ready-made programs available for different in each exercises. Even the sophisticated models like quadratic weights and other sort of things. So easily ready-made programs are available. Simply you run those programs, get the codes, and get the elasticity coefficients. So R is a good software nowadays, which is open access, freely available. Moreover, you have the ready-made built-in programs in that. Even SAS and other things, I don't know how many people are having access to that. So that way it is a bit inaccessible in today's world. General terms I can say is that you can use any software which has some inbuilt programming for the simultaneous equations. It will just take one more minute so that we can. So we have not to, now we got, suppose earlier it was price elasticity of milk, income elasticity of milk was 1.7, but once we estimated, imposed the restrictions, it increased to 2.4. Okay. So if I convert it into some table form, you can, yeah. So this is the price elasticity, this is the income elasticity. So income elasticity of milk is this, cheddar is this, processed milk, butter is that. If you ask me interpretation of that, I will not agree with this elasticity, because processed milk should have the higher elasticity as well as the raw milk products. But it's all about data actually. So let us not worry about what value we have got, but actually we got the expenditure elasticity. These cross price elasticity, it is a own price elasticity, all negatives, which is good sign. Means own price elasticity of milk, cheddar, and this is given by this center origin, this what we say, this line. And then we have cross price elasticity of milk with respect to cheddar, processed, and milk, and this. So we can use those things, and these are some graphics to show this weather observations of goodness of fit and other things. So this is how we can estimate few things. So can you share your Excel sheet of elasticity which you have shown? Of course, I can share with these sheets as well as papers. I have also published papers on elasticity, so I can give those papers and you can go into that. I know, friends, that it's not very easy to get everything in the first lecture. So this is was just for the glimpse purpose, and we really need to work. If somebody of you are having some interest in estimating the demand, food demand for your thesis purpose or for your students or for your research purpose, if you need anything, you can contact us anytime, and we can have a detailed a program or a workshop of 1 or 2 days on this particular model, because 1 hour, 2 hour, it is certainly not possible to understand everything. So we should go on in that. So what I tried today is that to just give a glimpse of the theoretical aspects and how we can have a transition from theoretical to applied aspects, estimate those things, just to show that. So don't worry if you feel that I could not get anything, because it's just the first thing. So if you could, if it could create some interest to you, then we can still work out on one-to-one basis or some other workshop or lectures. So thank you very much. I hope you could get something out of this. Any other questions or comments are most welcome.
So I think you have answered all questions what they raised. So even though it is theoretical, but I think theoretical knowledge is required to apply it properly in practical applications. And Dr. Shiven has already offered you one-to-one help also, like those who would like to work in this field. Some people are asking for sharing the SAS codes. Shiven, like
I can share, and I will tell me that how I can share. If you want, I can share in chat box right now, or
you can share with us, and we will share it on the group. So those who want, they can download their groups. So this is one way. So I think if there are no more questions, let us break for lunch, and thank